Greetings, ladies and gents, and welcome back at Semi Maths and Science Club. Today we are tackling some exam type questions. So I downloaded this resource from Stanmore Physics. It's a very nice website with a lot of resources. And remember, on our last session, we did the trigonometry or the Pythagoras trig type questions, and I said that on our next lesson we would do a exam type questions, because that section kind of it shows up a lot in the exams. So what I'm going to do in this video is that I'm only just going to dedicate this video only on the Pythagoras trig type questions. Of course, I'm going to do this the rest, of course, of the other, the rest are like 26.2 in this case in the other videos. But for today, I'm actually just going to focus on the Pythagoras trig type question. So I'm actually just going to do 26.1 in the other questions. So what I would suggest is that you pause, you try, and then you watch the solution. So this would be the paper that we're going to do. So I wrote that down so that we can just narrate that and write whatever that we might need to use. So they say if sine of 34 degrees is equals to p, determine the value of each of the following in terms of p without using a calculator. Now, what do they mean by that? So what they mean is that you are not allowed to calculate the value of p, the numerical value of p in this case. So whatever calculation that you're going to do on the equations, it must be in terms of p. Now what I'm going to do is that I'm actually just going to draw a diagram. Now remember, a sine of 34, in this case it's equals to p, but in this case we know that p is actually p over 1 when written as a fraction. So we know that sine is actually the opposite over the hypotenuse. So if I were to write, of course, a diagram, now yeah, I'm not very good at I always mess up. Let's see if we're gonna succeed. There we go. So of course we have 34, so this would be 34 degrees, so that's 90. So we know that, of course, sine is opposite over the hypotenuse, right? So this would be p, and of course the hypotenuse would be 1. And to find out the adjacent, in this case you would use the Pythagoras, and you'd eventually find that this value here, it would be 1 minus p squared. So that would be the adjacent there. And of course, what I would suggest is that when you draw a right angled triangle, just make sure that you have all of your angles in this case, because they might you might encounter a question that requires that. So in this case, we know that a complement of 34 is 56. So this would be 56 degrees. Now they say, of course, determine the value of sine of 214 degrees. So of course we know that's larger than, of course, 90. We always try to work with the acute angles, the ones that are less than 90. So in this case, this is bigger than 90. So what we're going to do is that we're going to reduce that. So if we reduce that sine of 214, you would get so this is how you would reduce it. So it would be sine of course 180 plus 34. And of course, if you reduce that, now remember, a sine is positive, of course, 180 plus an angle that's on the third quadrant. So this is 180 plus, so this is 180 minus, that would be 90 minus, and that would be 360 minus an angle. So this, we know that only 10 is positive on this quadrant, and only cos, and then all of them are positive there, and this would only be a sign that's positive in that quadrant. So on the third quadrant, of course, sign would be negative, so this would be sine, this would be negative sine, of course, of this would be 34. And we have, of course, the value for sine of 34, we know that equals to p. So this would actually be minus a p. So that's the value that you are going to get there. So they say, of course, they want the value, of course, of 68. Now, what you would notice is that we don't have 68, even though we tried to calculate that value and we got that it to be 56. That is not actually in the diagram, but again, even though it's not in the diagram, again, that's not a special angle. So what you would notice is that actually 68 is actually a double of 34. So this you can actually rewrite it as cos of 2 multiplied by 34. So, and you would notice that's actually a double angle. Of course, this would be cos of not actually, so this would be actually 1 minus 2 sine squared of 34. Now, if I, of course, I chose to use the last version of cos. Well, now remember, we have 3 types of the double angle for, we have the 3 versions, of course, for the double angle for cos. Now, in this case, so this would be equals to 1 minus 2. Now, sine of 34, we know that's p, right? But we squared that, so this would be p squared. So that would be, of course, the value for cos of 68 in terms of p. Now, they say they want the value, of course, for cos of 34 multiplied by cos of 22 degrees, negative 22 rather, plus cos of 56 multiplied by sine of 38. Now, I'm sure most of you can already notice that this is actually, it looks like the compound angle identity for cos, but of course on this side, but on that side you notice where we have cos of 56 multiplied by sine, so the names do not match on this side. So what I'm going to do is that I'm just gonna, even the angles for that matter, so what I'm going to do is that I'm just gonna try to rewrite this side such that it matches on what's on this side. So this would be, of course, cos of 34 multiplied by, of course, and we don't work with negative angles, right? So in this case, we're just gonna add 360 to that, and then of course 360 is on the first quadrant, so it's it's actually on the third, so it will be 360 minus 22. So in this case, we know that cos is positive there, so this will just be cos of 22 degrees plus, again, just gonna leave that for now. So this will be cos of 56 multiplied by, and again, if you reduce that, that's on the third quadrant, so this would actually eventually, now if you, this would be 360 minus 22 degrees. So if you, of course, you reduce that immediately there, you would have negative sine of 22 degrees. Now again, I'm just gonna say, so this, now before I even go to the next step, now you can already notice that on this side we have a cos of 34 and 22 degrees, but on this side we have 22 degrees, right? But in this case we have that 56. Now again, is there a way that we can try to rewrite that? Now what you would eventually notice is that we can actually just rewrite that cos of 56 as actually, let me just say that's cos of 34 multiplied by cos 22, so this will be minus. So I'm actually just gonna rewrite that as cos of 90 minus this would be 34, and that will be multiplied by, of course, sine of 22. Now the reason why I did that was because I wanted to change this cos, of course, to be sine, and also I wanted to reduce that such that I have it matches with the one that I have. In this case, it was supposed to be 34 because we already have a 22 there. Now, if of course we know that cos 90 minus an angle that's on the first quadrant, and in this case the name changes, right? So this would become a cos of 34 multiplied by a cos 22 degrees minus, this would change, right? The name changes, so this becomes sine of 34 multiplied by sine of 22 degrees. And what you would actually notice that that's actually a compound angle for cos, so this will be cos of 34 plus 22 degrees. So in this case, this would actually be cos of 56 degrees. And cos of 56, we have, let me just put that up there so that is visible. So in this case, we know that cos of 56, we have 56 on our diagram, and cos is the adjacent over the hypotenuse, right? So this would be p over a1, but anything divided by 1 in this case would just be that whatever value. So in this case, it would just be p. So this would be the value, of course, that would get in terms of p. So this is the first question. And for the second question, we're just gonna do now. I'm actually I was gonna do a question 1. I was gonna do all of them, but the thing is, I don't want to make this video a very long video. I wouldn't want you, to fall asleep while watching me, doing the math. But I was actually, I don't know if the time agrees. In this case, I'm actually just gonna try, to do that 3.1, because this question I've seen it in the exams a lot. So it would be very good if you get those marks. This is actually an easy 5 mark. So I'm actually just gonna do the first one, the second, and also the fourth one, and of course the seventh, 1.7 in this case. So I'm actually just gonna do that again. I would pause and you try, and then you can see you can watch the solutions. So what we have they say if, of course, sine of 12 degrees, I hope this is visible. So if sine of 12 degrees is equals to a minus sine, if cos of squared minus cos squared 12 degrees minus sine squared 12 degrees is equals to m, expressed without the use of a calculator, the following in terms of m. Now, of course, you can actually, one might notice that this is actually a double angle identity for cos. So I'm actually just gonna rewrite this. So this would actually be eventually become cos of actually 24 degrees. So this would be actually equals to m if I change that. Now to write a triangle for that, let's try this again. There we go. So actually we know that cos is equals to, of course, is the definition is for it is the adjacent over the hypotenuse. So in this case this would be m. Now remember, we have 24 there, we have 90, so this would be 1. And if you find that if you, of course, use Pythagoras, you would get this to be 1 minus m squared. So that's the value that you would get there. And of course, if that's 24 there, so that would be actually 66 degrees there. Now remember, you must always just try to fill in whatever information that you can fill before you attempt the question. Now they say they want the value for cos of 24. Again, we can already see that that would be equals to m. So this would actually be equals to m. Now they say of course they want the value for root 3 over a 2 multiplied by cos of 6 plus half plus a half multiplied by sine of 6 degrees. Now what one might notice, or what you might notice, is that root 3 over a 2, that's cos of 30 degrees. So I'm actually just gonna rewrite this to be cos of 30 degrees multiplied by cos of 6 degrees plus, of course, a half. We know that's sine of 30 degrees, so this will be sine of 30 multiplied by sine of 6 degrees. Now again, you can see that's an identity for cos. So this would actually collapse to cos of 30 minus 6, and this would just be cos of 24, and this would just become m. So that would be the value that you get for that. Now there is another way you can do that. Now the other way that you can do that was, now what you need to notice that the value that, of course, the angles that we know the values of would be 66 and of course 24 and 30, 45 and also 60. So what you would notice that you can actually rewrite that 6 by using 66 minus 60, and then you can just expand it and do the mathematical gymnastics, and you would eventually get to the same answer. Now they say they want the value for cos of 48, and again you would notice that 48 is the half, is actually a double of 24. So I'm actually just gonna rewrite this to be cos of 2 multiplied by 24. And of course you can see that this is a double angle for cos, so this would be 1 minus 2 sine squared of 24. Now you can use the other ones in this case. I just I don't know why lately I'm actually just choosing I always choose to use that. So this is 1 minus 2, of course sine of 24. In this case we know that sine of 24 would be the opposite over the hypotenuse, which is just 1. So this would be a root of 1 minus m squared. So that would be squared there. So this will just become 1 minus, now remember when we square that the square root disappears, so this will become 2 1 minus m squared, and this will become 1, of course negative 2 multiplied by 1, this will become negative 2, and that will become 2, of course m squared, negative 2 multiplied by negative m squared, that gives us that. So that would be of course, if we simplify that even further, so that would become minus 1 plus 2m squared. So that's the value that you would get. And for the last one, this is a very strange value. Of course it's not that hard, it's not that difficult, but yeah, I kind of battled for the first time when I was doing this question. Now this looks like the double angle identity for cos, right? But now there are many things that are missing there. So what you actually need to do is that I'm actually just gonna rewrite that to be a negative, of course, minus 2 sine squared of 12 degrees. And what I would also now remember, for us to use the double angle for cos, the one which says the one that says 1 minus 2 sine squared of an angle, would need to have a 1, right, and the negative 2 multiplied by sine of an angle. Now we don't have that happening there. So what I'm gonna do, I'm gonna put that one there, right? I'm gonna actually just put it there, and just watch what I'm gonna do next. So this is gonna become negative, so this will be 1 minus 2 sine squared of 12 degrees. So this is actually like that, but remember I've added a 1 there, so when I distribute that it will become negative 1, right? So I'm just gonna put a positive 1 there, because a negative 1 plus a 1, that gives me a 0, and of course a negative multiplied by that negative, it will actually lead me to that what I had initially. So in this case this would be 1 minus, of course this would be the double angle. So for cos, so this would be actually to be cos of actually to be, yeah, that's cos of 24. So this would just become 1 minus, that cos of 24, that's m, right? So this would be 1 minus m. So that would be what you get, the value that you would get. Now that is very strange, but as you can see, yeah, they love to ask very strange values. I kind of battled with that at first, but eventually I got I found the way to do that. So the first way you needed to acknowledge was that, of course, of course that we had a positive there, so the first thing that we needed to do was to change it, was to acknowledge that a positive is a negative multiplied by another negative, right? And of course we needed that 1 there, right? So I put it there, but what you are not allowed to just add a value just because you need it. So what you need to do is to reverse whatever that you put there. So in this case, it doesn't have any effects, it doesn't change anything. So in this case, that's how I tackled that. And of course, that's how you would get I think it was 4 marks, if I'm not mistaken, or 3 there. So this is the last question that we're going to do. Again, I'm going to do just question 13.1. So you can again pause, you try it, and then you watch the solution. So that will be for that question. I don't think I'm actually just gonna find the time to do that question, but what I'm going to do is that I'm actually just gonna find similar questions to that one, and then I'm gonna combine them and do them on a separate video. So question 3 says if of course 90 of course if A is between 90 and 360 and 10 is given to be 2/3, determine without the use of a calculator sine of A. So the first thing that we need to do, now remember that of course 90 and 360, so this would be in this quadrant, and on the second, third, and even fourth, on the fourth one. But in this case, we know that we can see that the ratio for sine is positive. So in this case, so it will be on that quadrant there, because we know that 10 is positive on this quadrant. So in this case, we would draw our right angle triangle on that quadrant. And of course, we know that the adjacent, so this would be where A is. So this would be the opposite over the adjacent, right? So this would be -3, and this would be, of course, this would be -2. And again, -2 divided by -3, that would give us a positive there. And again, you can notice we don't have the hypotenuse there, and to do that, we use the Pythagorean theorem, or theorem. I think that's the right way to put it. Now again, I would have r squared, that's what we want, and our x in this case would be -3, but we square that, plus -2, we square that, and then that would be 9 plus 2, that's 11, and the square root of 11, I'm just gonna leave it like that. So this would be just square root of 11. So this would be r, the value of r that you would get. Actually, I think that's not actually 11. So we know that 3 squared, that's 9, plus 4. Let me just not write something else. So this would be plus 9. So this would actually be 13. This would be 13. Forgive me, ladies and gents. So this would be 13, square root of 13. So in this case, so this would be square root of 13. Again, so we are, of course, they say we must determine the value, of course, of sine of A. So sine of A, in this case, we know that sine is the opposite over the hypotenuse, right? So this would be, of course, the opposite, which is -2 over root 13. So that would be the value for that. So they want the value, and that would be the value that we got there. And then 3.2, they say, of course, they want the value for cos 2 of A minus sine 2 of A. Again, we have A on that ratio there. So in this case, you can already notice that this is actually a double angle for cos, and this is a double angle for sine. But you know what? There's many ways you can do this. You can actually make this a compound angle identity, but it's gonna become a mess. So I'm actually just gonna make things easy for myself. So this is gonna become cos. I'm actually just gonna expand this using sine again. Let's just use cos for a change. So this become cos. This become 2 cos squared of A minus a 1. Now remember, we subtract that, and of course for the sine we only have 1, so this will be 2 sine of A multiplied by cos of A, and this will be 2, and cos squared of A, in this case we know that cos is the adjacent, so the adjacent in this case would be -3, so that's -3 over root 13. So that would be squared, minus 1 minus 2 sine of a, of course, that's would be -2 divided by root 13, and cos of a again, so this would be -3 over root 13, and you'd have if you square that, so this would be 2 multiplied by 9. So when you square that, you'd get 9, and then for that you'd get just 13, because the square and the square root they cancel each other. So we have -1 minus a 2 there, and those two, of course, you would get that to be 6, which is positive. And of course, on the denominator again, you'd have just 18, because when you multiply those, of course, the square root would cancel. Now, so what you would do from this position, again, we know, so this would be 18 over 13 minus a 1, so that's minus a 2, so this would be actually 12 over 13. Again, what I'm actually just going to do, I'm just going to combine this first. So this would be, of course, 13 over, this would be 13 minus 18. So this would be minus, of course, 12 divided by 13. I think what I'm actually just going to do to avoid all of that, I'm just actually just going to put that on my calculator, and let's see what I'll come with. So that's 13 minus a 1 minus 12 divided by 13. So you get the final value to be 7 over 13, but that's negative. So that would be the value that you get for that. Again, I just avoided, I was actually just gonna finish the whole page in this case. So this is the end of today's lesson. Now again, I'm actually just gonna find time for me to do a question that's similar to the one that I wanted to do. I'm just gonna actually find a lot of questions and combine them, so that we can do more of those, so that if they come up, you can know how to tackle them. So this is the end of today's lesson. I hope you enjoyed it, and I hope that it helped at some extent. Now, if it helped, you can always like. Of course, if it helped you, you can always share with your friends. Of course, if it helped you, it might help the next person. And if you have any question, you can always throw that in the comment section. Or if you have any topic that you would love me to cover next, or that you, of course. But until next time, this is Mike signing out. Sharp sharp.